Thank you, Stefano. So for about 1.5 years, we've been initially experimenting, and now we are aggressively using Golang to implement stuff on the Open Data Hub. We used to be mainly a Java operation, and so the very first question you might pose is maybe why? So why would you use Go, and would you not use Java? So I'll now do like 2 or 3 minutes of Java bashing, so please Java developers, excuse me. I am a long-time Java developer, so I am quite familiar with it. It's all in jest. I actually don't believe it's a bad language. I just think for our use case, it's not optimal for the reasons I will get into. So this is the first one. So we are playing a game of Spot the Java. This is a list of pods on our Kubernetes cluster. And then you see the 2 columns, which are the CPU usage and the memory usage. So the game is, can you spot the Java programs here? So I think it's quite easy. Like everything that is below 5 megabytes of RAM is Golang, and everything that's above 200 is Java, also going on 600. And to remind you, these are like cron jobs. They run like once an hour and do something. And they sit there, and this is already garbage collector optimized. So this is aggressively running some parameters so that it returns memory. It might have to do with the implementation. So again, I'm not bashing Java as a language as a whole, but how we implemented them, it is that bad. So, and actually, since we have a very large number of these small services, and they're growing and growing, this is an actual problem. Because if we have like 40, 50 of these services running around, if they use 4 megabytes of RAM or 500, makes a big difference. And also, since we're using Spring, they consume a lot of CPU on startup. So we had some issues on a cluster already where all the applications we started up, consumed all the CPU, all completely tilted, and continued to add nodes and containers and so on. So this is very relevant. Then there's some other stuff that I think a lot of you know. This is a typical Java class consisting of 5 fields and 200 getters and setters. Doesn't actually do anything, it's just a struct. Then we have these kind of files. So every Java project has these kind of files. You open it, and it's just the app interface, something, component, doesn't do anything. You don't know. It's just a file. You open the file, and that's in there, and you say, okay, it's the wrong file. I have to look in another one if the code is there. And then there is also this. So in Java, we have, like, I like to call it the auto magic. So you have a lot of these annotations, and they just do magical stuff. If you add the wrong annotations, they don't do the stuff. They usually don't give you an error. They just don't do the stuff. You get no feedback. Sometimes you update the dependency. It doesn't do the stuff anymore. You don't know until you deploy it into production. Then you figure out, oh, my authentication doesn't work anymore because the annotation now has to be somewhere else. I don't know. And this is an example from a Java program we migrated. So you see, this isn't even a bad one. So this is not bad quality code or anything. I'm not knocking it. It's just standard Java stuff. You see, there's like 5 files, and it was 800 lines of code. And exactly the same stuff in Go took us 200 lines of code in one file. And it even has unit tests. So yeah, so what we don't like, why we decided to stray away from Java a bit is we don't like Spring. Like Spring is very heavy, it consumes a lot of resources. It gives you a lot of stuff, but it's just hard to get into. It has a huge learning curve if you're not from outside, and also it keeps updating the documentation. You find is sometimes out of date on the internet because it keeps adding breaking changes with major version updates and so on. And it's doing a lot of this magic stuff. So you actually, if you look at your main function, you don't see what the program does. You have to open some config file somewhere, like some class with some annotation, and you see, oh, all my application is actually injecting some HTTP parameters. I didn't know until I opened this random class file. So yeah, and it has a lot of boilerplate. We have these very, very small programs. If you have a huge application, this might not be a problem, but if you have these very small programs, it tends to be a huge lot of boilerplate and very little code just to set up stuff. Now, could you write Java in a way that avoids all these problems? I think so, absolutely. So you can use minimal dependencies. The JVM doesn't use 500 megabytes of RAM. The JVM used to run on Nokia cell phones, if you remember, like all the applications that were written in Java. So it's not a problem with the language per se, but I think the way Java is taught, the way Java is used, the standard way to use Java, unfortunately produces these kinds of problems. So I think it's a problem of the ecosystem of Java, not the language itself. But most of the advantages you get from Java is by using the existing ecosystem. If we constrain all our contractors and all our developers to use a very specific subset of Java, to use some esoteric minimal libraries and so on, you kind of lose the advantage of Java. You cannot use all the Spring goodness. And so just to try it out, we tried Go, and we liked it a lot. So why did we land on Go? First of all, I have to say we were at the Go developers track at FOSDEM, and that was the most beautiful thing. So the Go community is very tightly knit. It's very not corporate. It's very community-driven, very inclusive. So we liked that a lot, and that was where we first came in contact with Go. And then I think it's also a good language for the stuff we do, because it's very stable and mature. So some of you maybe think of Go as a new language, but Go was released in 2009, so it's 15 years old. And I think in 2012 it was the release of version 1.0, and now we are at 1.24. And all of those 1 point something releases are completely compatible. So Go has been stable since 2012. Like you could run Go code from 2012 probably on a Go compiler today without issues. It's very performant, as you've seen. It has an awesome developer experience. That's a thing that the Go creators very much optimized. It is very simple. It is somewhat sexy. Like it's not the most sexy language there is, but it has some appeal. So a lot of developers say, oh, well, maybe Java, PHP, I don't know, but Go sounds a bit fun. So that's also important for us since we're publishing open source code. It's good if the language is interesting, then maybe someone will contribute if it's not some ancient language that nobody really likes to use. I'm not saying Java is that, I'm just saying a hypothetical language we could have used. And also to add, we saw all our infrastructure we use, like all the stuff we use is actually written in Go. We didn't notice before, but our proxy server is written in Go, Docker is written in Go, Kubernetes is written in Go, Terraform is written in Go. It seems to be all the stuff is written in Go that we use in the end. All our clients we use to interact with Kubernetes and whatever, it's all written in Go. So it seems to be quite widely used in the space we are in. So now I will attempt to give you a 5-minute introduction to Go. This is the gopher. It's like some kind of small rodent. It's the mascot of Golang, if you don't know. So what I did, what is Go? Go is a C-inspired, imperative, statically and strongly and structurally typed, portable, garbage-collected language that compiles to statically linked binary. So now you know what it is. I like to think of Go as C, like the language C, as you remember it through roast interclasses. Because sometimes you have the experience, oh, I used to program C, it's quite nice, it's quite simple, you have structures and so on. Then you start writing a C program, and the first time you interact with a string, you think, oh, now remember. Then you have to do malloc, and then you say, okay. And Go, you write Go like you write C code, but you have a garbage collector. You don't have to do memory allocation and freeing. It has type inference. You don't have to write the times everywhere. It very much has batteries included, so there's usually in Go you do 0 or very minimal dependency development, like for doing HTTP requests and so on. There is everything's already there. You do like http.get. And you do an HTTP request. There's no setting up a client, something. It has a very fast and cross-platform compiler, so it's very easy to compile programs for other platforms, and it's instantaneous, pretty much. And it has very good concurrency support. That's one of the killer features of Go, so it lends itself very well to writing servers, backend stuff that uses multiple threads. And this is Go. I hope you can read it. So the first part is how you declare a variable in Go. You just, it's just pretty familiar. You have the usual strings, you have the usual ints. Then you have arrays, which is like a normal array, as you know, with a fixed length. You have slices, which is a variable length array, so Java vector. And you have maps, which are hash maps. So these are the basic types. Then you got for loops. You can loop over a range. You can do like you can loop over the indices of an array. And Go also has pointers. So don't be alarmed. The pointers in Go are actually what all the variables are in Java. So in Java, usually you have variable references, and pointers in Go are pretty much work like Java references. It's just a value that references something and can also be null, which usually variables cannot be null in Go. So all the types have 0 types, so they're initialized with safe memory. That's a contrast to C. Then you see the next thing, there is a function definition, but with a twist. It's a lambda function. So I assign a function to a variable. So you see Go has first-class functions, so it supports some way of functional programming. You can pass around functions like you could in any functional language. It's more functional than Java in essence if you look at the basic syntax. And here you see another particularity of Go. Go has multiple returns. So a Go function can return n things. And usually it does. Usually a Go function returns a thing and then also possibly an error. So that's one very strange thing. Yeah, then I skip over some stuff, I think. This is the type system of Go. Go has a bit of a strange type system. It uses something called interfaces. So if you're familiar with Python, so what it's called, it is structural typing. So it's not nominal typing like in Java where you say this is an X, and then you can only use X for the thing. Go is similar to Python. Python has duck typing. So in Python, if something has a certain structure, if it has these 3 methods, then you can use it as something. So in Python, you just say, does it fulfill the structure? Okay, it doesn't. Yes, then I can use it. And Go is similar. For example, here I'm defining an interface to stringer. So I'm saying that there is a thing that has one function to string that returns a string. And then I can, for any type, here I say, okay, I have a special implementation of a float variable. I just implement the toString function for the type, and now I can use it as a toStringer. So down here in the function, I can. So basically, this is not only an example. This actually exists in the Golang library. There is an interface called stringer, and everything that outputs a string is like the toString in Java. You just have to implement the string method in Go, and then it is a string. So the type system is quite different from what you're used to in Java, C++, and so on. It takes a bit to get into, but it's quite good. And then the last thing in Go has concurrency primitives. It has 2 very important things. It has Go routines and channels. So Go routines are basically threads. But there are lightweight threads. They don't use an operating system thread. It's like pooled. It's very, very performant. You can have thousands of threads, and it still runs on a, I don't know, dual-core machine. And how do you use them? You just write Go. That's why the language is called what it is. You just write Go and call the function, and then the function is executed in the background in some thread. And the other thing you have are these channels. Here I'm making a channel. It's just... It's a first in, first out queue in the end. So you just have a data structure that can be used by multiple threads at the same time to synchronize. I'm not going too much into detail how they work, but suffice to say these are the 2 primitives. And now the interesting thing is you have seen all of Go. There is nothing else. This is all the syntax of Go. And this is how you run it. You just write go run test.go, and like a script language, it just does the thing. So everything you've seen is a valid program that runs with this output. Okay, then Go has awesome tooling. So these are the tools that Go has. It has Go build, obviously the compiler. It has built-in unit testing, Go test. So there's a standardized way in Go to do unit testing. You just name a class, something, a file, something underscore test, and it's recognized as a unit test. It isn't included in production builds. And so you don't need any external framework to do unit testing. It's completely integrated. It has Go mod, Go get to do modules. So package management is also integrated in the language out of the box. It has Go format, Go vet. So Go has an auto formatter with one single configuration that everyone always uses, and I think you cannot change it. So every Go code is formatted the same. Any Go code you look at in the world looks the same. Has Go please, this is a language server, and it also has some runtime profiling and tracing, like Java, for example, with heap dumps and so on. So how is it going along? So how are we using it? Pretty much all our new stuff is done in Go nowadays. So these are the repositories from our GitHub organization. And yeah, it's like, I don't know, 15 repositories. They're all written in Go. All our new data collectors are written in Go. And so far, we like it a lot. What we love is it is easy to learn. As you've seen all the syntax there is. It is very easy to read. All Go code looks the same. All Go code is dumb and stupid because there is usually only for loops, structs, and so on. You cannot do very fancy abstract stuff. It's very difficult to do. It is blazingly fast, as you've seen. It doesn't consume any resources. It has great tooling. And you can use minimal dependencies, which also means less dependency hell, less updating dependencies, less vulnerabilities, and so on. It also has a very great welcoming community and is not as enterprisey as Java and so on is. Yeah. What we don't like, channels and Go routines are foot cannons, so it's very easy to shoot yourself in the foot with those. It's a bit like pointers in C, so you have to fail 2 or 3 times to know, okay, maybe I shouldn't use them that much, or maybe I should be more considerate in the usage. The library support is not the best in the sense of it's not Java, but it is very good. It's like it's not like a niche language. Documentation is a bit of a toss-up, so sometimes you find good documentation, sometimes not. And the type system is not very powerful. So if you're building something very big and abstract, maybe Go is not the best language to use. For example, some very complicated ERP system or CRMs with pluggable modules, maybe Go is not the best. And also it doesn't have as much of a huge developer community as Java, but we hope that maybe you can change that. If you're interested, check out Go and be part of the Go community.